So guys, 12.5, optimization problems. Now, this is a kinematic question. So who does physics and all that sort of stuff here? Okay, so there's a few sort of kinematics questions coming up over the next couple of exercises. Can anyone tell me what displacement is?
How far? It's like not the same as distance. It's how far you are from the point. But if you go back, it's like how far from A to B.
Okay. Yep, how far from there. Okay, yeah. So if sorry, I'm not a physics teacher, but if you go around there, the displacement is
Just from the start point.
yeah, or actually something like that.
Zero.
Displacement is zero, but the distance is different. Just for those people who are not doing physics. Now, we have an equation here. The question is, find the maximum and minimum displacement. What's the key words here of us to in regards to we're going to derive, but why? That's what I'm trying to say. What do you see?
Maximum and minimum.
Maximum and minimum. When you see these words straight away, the alert should be up in your head to derive. So we're going to derive this right now. T cubed on 3, if I derive that. T to the 2 minus 4t squared. That's 8t and then plus 15. Okay, once we've derived it, what's the second natural step that we're going to do with this equation? Perry? Make it a 0. We are looking for a 0 gradient, which is either the max or the min. And can someone tell me what can we use from the past about how to solve this for t? A null factor law. What two numbers multiply 15, but when you add, subtract, it's a negative 8. 3 and 5.
No.
Negative 3 and negative 5. Okay. So t equals 3, and t equals 5. Good. So we're up to that stage. Now, we are now going to, if I have a 3 and a 5, we do not know if it's going to be like this. Well, you kind of do know, by the way. But let's use a table. And our x dash t and our slope that we did type in t and our slope. 3 and 5 is where we want to be, but we want to look in between. So naturally, what numbers are we going to test out across 3 to 5? We're going to do a 4, we're going to do a 6, and we're going to do a 2. Okay? And we know our x dash t at 3 and 5, they're going to the slope's going to be flat. These are going to be
0.
Our zeros. And how are we going to test what the gradients are on each of these in-between spots of 6, 4, and 2? Say, what are you going to do with the 2? How are we going to make use of that? Where are we going to put it?
In the equation.
In the equation. Okay. Which one?
First one.
The second one.
Yeah, that's just the top one. That's
Is that what you meant? Okay. 4 minus 16 plus 15. That right, equals 3. So therefore, that's our 3. And we're going to make that a positive, like so. Okay. If you do sub them all in, okay, you're going to get a negative for the 4 and a positive for the 6. Okay. So like so. I'm not going to substitute each of those values in. So therefore, we can see that at 3, what sort of stationary point do we have, Zach? At 3?
Maximum.
It's a maximum. And at 5, it's a minimum. So we know that a graph is going to do generally something like that. Okay. Almost done. Have we found the maximum and the minimum displacement? Nathan, have we found the maximum? Have we answered this question?
No.
Why haven't we? What have we found? We found something, but Nathan's saying we haven't found the question. But what we found something. Would anyone else like to? We found the derivative. Okay.
Time.
We found the time. Okay. Can you be more specific, Zach?
The maximum and minimum time.
Time. Okay. So that we found the times, as Zach's saying, when maximum and minimum has occurred. That's not displacement. We found the time. So therefore, what's our next natural step? Manny?
Put the times into the equation on the left.
Good. Excellent. So t equals 3. Just sub them in. Okay, if you complete all that, you're going to get a 19. And for x for 5, if you complete all of this, you should get 17 2/3. Please make sure you do not round off into decimals, please. If it's a whole decimal, that's fine, but keep it as fractions as possible. Last step. What's the... Let me just get some space first. Can everyone get your CAS and graph this, please? We'll need to refer to this question. I'll rewrite the equation. I'm going to sketch what's on your screen. Okay. So we've plotted in our maximum and our minimum. Are we good with that? Now, they call this a local minimum and a local maximum. Does anyone know what's the highest mountain in the vicinity of Metro Melbourne?
Man, lizard.
Where's that?
Oh, something like that.
Okay, yeah. It might be a bit further out. If we shrink it back down, the highest mountain, I think, is in Bundoora, Mount Cooper, within the sort of vicinity of the city of Melbourne. Obviously, Mount Dandenong, let's go further out, going to have the high mountains. But when we refer to Mount Cooper, um, that's a local mountain highest point. It's not the biggest, but within the area, it's the highest. In the same way, we've got 319 as a local maximum and a local minimum. What am I trying to say here?
There's there's other ones.
There's other ones that are higher. And if we're looking for other ones that might be higher, what must we consider in the question? The domain. So here is really important. Your domain is just as important as the actual equation. You must always focus on that. So if you look on your CAS, if we go to 6, we must look at 6 and we must look at 0. And we call these endpoints. So we must look at what's happening at x0. And we know if I punch in 0 into this equation, what am I going to get? 1. I'm going to get a 1. And if I punch in a 6, well, you can use your CAS if you want. I'm just going to sub it in like so. If you get all of that, 6 becomes, did anyone find it on your CAS? 6 becomes 19 again. So our graph looks a bit like this. Hopefully I join the dots like so. And therefore we can now answer a maximum displacement and also a minimum displacement. Can someone tell me what the maximum displacement is? How high does this particle go on the graph?
18.
It's 19.
No,
Yeah.
19.
Oh, what? Sorry.
It can go from 1 to 19.
1 to 19. Sorry, I'm not sure what you said.
Because it goes from 1 to...
Oh, okay. I see what you mean. Okay. I see what you mean. That's a deeper question. I'm just calculating the, I don't know how to explain it. But on the max, it's 19. Okay. On the minimum displacement, we have a local minimum here of 17 2/3. But what's the real minimum here? 1. It's 1. It's down here. The main lesson for today, even though you've calculated a max and a minimum, does not mean it's the max and minimum for the question. You must always calculate your endpoints to see if they're either higher or lower values compared to these guys here. That's the main point of today. Do we have any questions? Okay, this is 12.5.